That's me. Hello, ciao. My name is Mattia Battiston. I'm originally from the small town in Italy called Verona. You might know it as the town of Romeo and Juliet. It's a very romantic place. I'm a software developer for Sky Network Services. You probably know who Sky is. We are the department in Sky that does the telephone and internet. So the way I usually explain it to my wife is that we make the internet work most of the time. If you have a Skyline and it doesn't work, it's not my fault. Over there at Sky, I help my team and some other teams get started with Kanban on top of whatever they're doing and use metrics as well. So this is a shorter version of an internal presentation that I do for other teams, and I use it to share the experience from the team I work for about metrics and what we've learned from them. I usually suggest that teams have a little bit of knowledge with Kanban before we start talking about metrics. But because you guys are in a continuous delivery meetup, you probably know already about things like lead time, limiting work in progress. So you probably should be able to follow this with no problems. So let's start with why. Why should I bother collecting metrics? What problem am I trying to solve? In my team, we identified these two main reasons. The first one is we use metrics to drive our continuous improvement process. So one of the Kanban core practices says evolve experimentally. We use metrics to get ideas about where we should be improving. Then we introduce a change. And we use metrics again to validate whether the change was successful or not. So it's one of the continuous feedback loops that we get from our experiments. And the second main reason is that we use metrics to do forecasting rather than estimating. I don't know if you have been following the no estimates tag on Twitter or the probabilistic forecasting, but it's about rather than just using gut feeling when you're estimating, it's about using your historical data to try and use the data to forecast what's going to happen in the future. This second topic, forecasting, is quite big in itself, so tonight I'm only going to touch on it, but if you want to know more about how we use it, I'm happy to talk about it later. You can Google people like Troy McGinnis if you want to know more, or there are a bunch of links at the bottom. The typical reaction of people when I start talking about metrics to them is, no thanks. And that's because we've all seen metrics gone horribly wrong in the past. Who here uses velocity? Don't be shy, we all did. I was guilty. We all know what happened with velocity, right? Managers started demanding that teams reach a particular velocity, so teams understood that it's enough to double all the points for each story, and you look like you're going double as fast. That's the problem with almost every metric, really. They're often easy to game, to cheat, and you could end up creating more dysfunctions rather than helping. But that's why in my team we came up with this checklist of good versus bad metrics. And the most important thing is that we use metrics that look at improving the system rather than at the performance of single individuals. You might know this guy, Edward Deming. He's the guy that studied the Toyota production system and basically brought it to Western people, more or less. In his studies, he found this interesting evidence that 95% of the performance is attributable to the system and only 5% to the people, which means that if you want to improve your performance, you can't just ask your people to work harder or to do overtime or to try harder because, well, probably they're already doing the best they can, but also they can only have an impact for a 5% on your performance. So what we want to improve is the system around the people, remove the blockers, give them an environment where they can do a good work. So the metrics we use look at the system rather than individuals. They need to be actionable, so we use metrics to take decisions, not just to feel better about ourselves. And if we do try to cheat, we end up doing something good. They are in our influence. We never use metrics that we can't do anything about. Otherwise, we just end up being depressed about them. We never use our metrics as a target. They are just a feedback loop. We are more interested in knowing whether we are improving rather than hitting a particular number. It's about answering yes or no, we are getting better, rather than reaching a particular lead time or velocity. Therefore, we usually express them as trends rather than individual numbers. And we try as much as we can to use leading indicators rather than lagging. So we try to look at metrics for problems when we can still do something about the problem, when the problem is still happening, not just afterwards. Before I go into explaining the metrics we use, let me explain how we work. This is the main board of the team I work for. You might notice that it's a physical board. We do have an electronic tool. We have Jira. Our Jira is configured with a very generic workflow. It's just to do in progress done. So the real workflow is actually done on physical boards. Our process starts here in the next column. These are the 3 next top priority stories that we have agreed to work on. You see all these colored placeholders. They are our WIP limits. So we have these physical envelopes where we put the cards that we print or deposit it, and they represent our WIP limits. The next column is our commitment point. So when a card enters next, we have committed to working on that story, and we have agreed that it's the next top priority, and we should work on it as fast as we can. It's important to recognize your commitment point because that's when your lead time starts. The lead time in Kanban is defined as the time from your commitment point to your first infinite queue. Stories then go into development. You might notice these avatars. We work in pairs. So here we had 2 pairs working on the same story. And through something that we called functional testing, and then into this column that we call waiting for cut. Most of our applications still follow an iteration-based release cycle. This is because historically we've been following a Scrum process of 2 weeks iterations. So most of the legacy applications still follow an iteration-based release cycle. So they wait into this column until the end of the iteration. At the end of the iteration, we can do a cut, and that cut goes through a month of release testing, and then it's deployed to production. But for newer applications, we can follow an on-demand release cycle. So as soon as a story is tested, we can do a cut and try and deploy it as fast as we can. And then we also have some stories that we call direct. They are just things that go directly from development to done. They are typically small tasks that we just have to do, like answering an email, creating a report, helping someone. So things that don't really follow the normal process, but that still have to be done. The point is that these 3 things are 3 different work item types based on the fact that they follow a different process on the board, or they might go through the same process but at a different speed. And it's very important in Kanban that you recognize your work item types, because most of the metrics only make sense on a per work item type base. In particular, the time of on-demand stories, the lead time, we take it as the time from next to done, because we have the full control over the full life cycle of those stories. But for the iteration-based stories, those stories have to wait here until the end of the iteration, and then they have to stay in release testing for a month. We can't do anything about it. So we only optimize the time from next to cut. This is how we collect our data. There's no rocket science. We print our cards, and when we print them, we put this grid at the bottom, where A, B, C, they represent each column on our board. And whenever a card moves from one column to another, we have a rubber stamp that we bought from Amazon, and we stamp it. So we are recording the transitions of a story through each state. And that's it, really. With this simple amount of data, you know how long the card has been in each state, you know what your lead time was, you can reconstruct how many stories were in each state at any point in time. So this is all we capture, really, the transitions between states. And every now and then we get all those dates and put it into a spreadsheet that calculates all the rest of the things for us. But we are simply recording some basic information about the story, and then the dates when the card entered each state and how long it has been in that state. It's worth mentioning that we tried some tools, but there is a reason why we use a spreadsheet. You can use tools to record the data for you, as long as the tool reflects reality. And that's not the case for our electronic tool. The way we use Jira for various political reasons doesn't reflect reality, so we can't rely on the data that is in Jira to get this data. But even if you do have a tool that you use for real and you have the right dates in it, I would still suggest that you export the data when it comes to analyze it, and you put in a spreadsheet, because what you want to do is kind of data mining. You're going to analyze the data in ways that a tool can't predict, and most tools are quite rubbish at doing it. It's worth mentioning that there is a guy there, Chris Young, that created a very interesting tool that connects to your Jira and extracts a lot of these metrics for you.
It also works with Fogbugs now as well.
Okay, oh, that's great. And there is a link to his GitHub page at the end of the slide, so you can go and check out this tool because it's really nice. Right, yeah. Did you have a hand raised? Sorry.
Yes, I had a question. So you made a good point that most of those tools do suck, and people use Jira for reasons. I completely agree.
Yeah.
But working remotely or etc. There's a limitation having it on the wall. I mean, how do you?
Yeah, definitely. But we are lucky enough to all be co-located. I guess that isn't a problem for us. If we were distributed, we would have to use an electronic tool for real. So maybe we could rely on the tool to collect the data for us in that case. But I would still extract the data then and analyze it in a spreadsheet. And hopefully you'll see why. Oh, by the way, this is all the maths involved. Some people get scared by the amount of maths involved when in metrics, but actually it all fits in one slide, and you probably all remember it from your days at school. And the nice thing is that even if you don't remember it, all the formulas are already there in Excel for you. Have you ever seen one of these before? I guess the cumulative flow diagram is probably the most famous diagram that you come across with Kanban. Most tools try to do it. Not many of them do it properly. You probably know already how it works. For each day, you're counting how many stories are in each state. So on this day, I know that I had 20 stories in done, 7 stories in release testing, 1 story in development, and 3 stories in next. And you plot this for each day, and you get this type of diagram. This diagram is all about flow. The name kind of gives it away. It's about finding whether you have a good flow in your system, whether the work is flowing in a nice way through your system. And if it does, you would see thin lines growing at a steady rate. And it's very pretty and colorful, and it looks nice if you print it and put it next to your board. But what I find is that even if this is so famous, a lot of people don't really know how to use it in practice. Like, what can I read in a diagram like this? What can I use it for? So this is what we use it for. We use it sometimes in retrospectives to talk about a period of time, to talk about the work that was going on in a particular period of time. For example, this one is from a time when we had only 1 tester, and we had a policy from the tester manager that only testers can do testing. Developers are not allowed to help testers. And you might be able to see this green band growing and growing there. And that's the poor guy that couldn't keep up with testing, so all the stories were piling up, waiting to be tested. Eventually, he managed to catch up with all the work. But we printed the CFD and had a retrospective with the tester manager and showed that the impact of his policy was that one, and we managed to make him change idea. We use our CFD to validate our experiments. For example, on the left-hand side of this one, you can see that the lines are quite flat. There isn't much work moving. Flat lines are the worst enemy of flow. At the time, we had 6 developers, so 3 pairs. And we put the WIP limit of development down to 2. So we always had 1 pair spare, 1 pair in slack mode, like we say. And this is the effect on flow. The bands are now growing much faster, and there is a much better flow in our system. We use a CFD to decide what to work on today. So if we see flat lines, we might decide to take some actions. If we see any band growing too much, we might take some actions. And some people say you can use it for forecasting, because you might have read that you can read the amount of work in progress and your average lead time in your CFD. It's true, you can get an idea about those 2 pieces of information, but if you're keeping track of those dates that we are collecting, you can calculate those data that data in a much easier way and in a more reliable way as well. So if you only have a CFD, that gives you a nice indication about your WIP and lead time. But if you have other data, you have better ways for extracting it. There are a number of patterns that you can spot in a CFD. These are taken by this really good article by this guy called Pavel Brodzinski. And it's a link, so you can go and read it later. It goes through all the various patterns that can happen inside a team and how you would see them reflected in your CFD. But just the most common ones. The top left one, when lines are diverging, it means you're starting more work than you're finishing. So you probably want to introduce some WIP limits or have tighter WIP limits. This one is probably the worst enemy of continuous delivery. When you see those steps, it means that you're moving things in big batches. This is, for example, a team that might deploy to production once a month. So all the stories go to production together once a month. Flat lines, they represent work that is staying in the same columns for a long time, so you don't have a really good flow. Probably your Scrum Master or your leader should investigate why that's happening. we have this slide printed by our board so that people can use it to find things in our CFD. Then there are some metrics that we use for delivery time. This one is quite famous as well. It's called control chart. And you usually see it implemented with dots rather than bars, but in our spreadsheet it was easier to do with bars. It still works the same. Each bar represents a story, and it shows how long that particular story has taken. So this story has taken 9 days, 2 days, 3 days, etc. And then this green line is the median. And this top red line is telling me that 80% of our stories take 10 days or less to be completed. And this one is telling me that 25% of our stories take 3 days or less to be completed. So whenever a story falls outside those boundaries, that is a very interesting story because it has taken either longer or shorter than usual. It's an unusual story. So it's a great opportunity for improvement. We want to talk about that story, understand what went wrong inside that story that made it that slow, or what was particularly good in those stories that we can do more of and try and improve our process. So this chart is really good to print and bring into retrospectives to find opportunities for improvement. There are some stats that we look at about our lead time and cycle times. Mostly we use the median rather than the average because it's less impacted by outliers. We look at standard deviation to get an idea of the variability in our system, but you need to be careful because this is not a normal distribution. So standard deviation doesn't apply in the usual way. And some percentiles about our lead times. And we also represent the lead time like this, that's the median lead time for each iteration, just to spot trends, and so we can see that the lead time has been going down regularly. It's really important to notice that we have an all-time view and a since a particular point in time view. My advice would be to not use data that is too old, because if you're truly being agile or doing Kanban, you're supposed to be continuously improving and continuously tweaking your process to improve your performance. So data that is too old should not be relevant anymore. So you have to decide how old data you want to keep, but we usually look at the last 5 or 6 months maximum. Right. If you've ever felt bad about estimations, this is probably this slide that you want to take away with you. This is called the lead time distribution, and this is a count of how many stories have taken how long. So this is telling me that 6 stories have taken 0 to 2 days to be completed, and then 12 stories have taken 2 to 4 days, and 7 stories have taken 4 to 6 days, etc. So you do this count of how many stories have taken how long, and usually you find this type of curve that goes around your bars, and this is usually a particular type of distribution called Weibull distribution, and there is a bit of theory behind it that tells you that you can draw some, you can get some information based on the actual shape of that curve, but it's a lot easier to understand than it sounds. And I usually express it in this way. So because I know how many stories have taken how long, I know that 13% of our stories have taken 0 to 2 days, and 26% of our stories have taken 2 to 4 days, and so on. So if I do a cumulative sum, I can tell you that 54% of our stories take 6 days or less, and then 83% of our stories take 10 days or less. And this is data that you can use to change the type of conversations you have with people. So when a project manager comes to us now and says things like, I really need this story done by the end of next month, when should we plan it in? We say something like, well, if you really want to be sure the story is going to be done in time, we should start it 10 days in advance. That way we are 83% confident that it will be done in time. Or, if you feel lucky and you want to risk it, we can start it 6 days in advance. But that way we have almost 50% chances of the story not being done on time. So it moves away the conversations from give me an estimate to can I afford not to do this piece of work?
Sorry, is this based on stories that haven't been explicitly estimated themselves?
Yes. And it's really important to remember that this is only for a single work item type. So different work item types will have a different shape and different probabilities. But what we do now, instead of estimating, so let's say a business analyst comes to us with a requirement, we do a story breakdown, so we still do analysis and identify the number of stories that we would implement, but then we use this data to give out a forecast rather than an estimate. We don't spend our time going through each story, assigning points to each story anymore. We run a simple Monte Carlo simulation using this data, and we get a forecast.
How do you break the stories down? So how do you know like, if it's a massive story? How would you break that down?
We kind of go by usual. So we know the usual way we split stories. So we try to do the smallest piece of vertical functionality that we can, that it should deliver some value for an end user. But we don't really stress about all the stories being the same size, because we know that they will follow this distribution. So we will have mostly small stories and some occasional big story, but we assume that it's going to follow the same distribution that it did in the past. So as long as we keep our usual way of splitting stories, this distribution will keep true.
Yeah, how many different work types would you bring through?
In our team, we identified the 3 work item types that I showed on our board. Yeah, it's okay. And that's based on the fact. Yes, and that's because they are things that follow different rules. So they might follow a different columns, they might skip a column, or they might have different policies. So you can't apply the same numbers to them because they will have naturally a different lead time. A good trick is to look at this type of shape, and if you don't find this type of skewed distribution to the left, you're probably mixing different work item types. The chances are high that you're mixing different work item types. Especially if you see 2 peaks, for example, you might be mixing 2 things together. The information is great, but it's still quite a lagging indicator. So it gives us information after the stories have finished. So we came up with the concept of the story health to get a leading indicator. We look at how long a story has been in progress for. So, and for stories that are still in progress, we say, okay, if the story has been in progress for 0 to 6 days, we know that at least half the stories stay in progress for that long, so it's probably fine. But when it goes over 6 days, it becomes yellow because it's starting to take longer than they usually do, and then red and black. And at stand-up, we would look at these colors and decide what should we work on today. If a story is yellow or red, we would put 2 pairs on it or try to escalate problems. This is what we used originally to drive our release improvements. In blue, you see all the time that the story has taken to go from next to being tested. So blue is the time that the story has taken to be implemented. And in pink, it's all the time that the story has just been waiting for the cut or going through release testing or through whatever process the rest of the floor wants to follow. So this is all time wasted for the story. This is all time that the story could have been in production for, delivering value and giving us feedback. And we use this chart to go to our release managers and say, look, this is how much time and money we are wasting on stories. Can we release more often? And that's why for newer applications, we managed to do an on-demand release cycle.
That's it, that's the lead time from ready to deploy to support.
Which one, sorry?
The pink one, yeah.
The pink is from the story being tested, so when we say the story is ready to actually be in production. So it might be quite context specific for us, but it's an example of how you can use the data you collect to drive your arguments with people in your company and get data for what you're saying. And you tend to be listened more if you go to a meeting with this type of information. We use some metrics for predictability. And the most important one is definitely the throughput. Throughput is quite a simple metric. You simply count how many stories are done in a particular period of time. The rest of the floor still follows the 2 weeks release cycle, so we naturally follow the same period of time, and we count how many stories are done in 2 weeks. It's quite interesting, though, that if you're mixing different work item types, like we do, some iterations could have a very different throughput, because maybe in this iteration we were working on an even split between one type and another type, but then in other iterations we might be working only on one type of stories, and so the throughput might be quite different between different iterations when we are mixing work item types. And then we keep track of the daily work in progress, simply counting how many stories are in progress on the board. It's all calculated by those days that we record. And we take the average daily WIP over an iteration. And we use those two pieces of information, the throughput and WIP, to apply Little's law. Who has heard of it? Have you heard of Little's law? Well, Little's law says that your average lead time is given by your average WIP over your average throughput, which in simple English, it means that when your WIP is low, so you're working on only a few things at a time, your throughput will be higher, so you will get more things done, and the lead time will be lower, so those things will be done in a shorter amount of time. And because of that strange mix of work item types that I was telling you, it's not always visible, but if you look on this area, you can see that the cycle time here was quite high. We have a high work in progress and a very low throughput. Then the WIP goes down, the cycle time is now quite low, and we have a really high throughput. Then the WIP goes up again, and the cycle time is quite high again, and the throughput is low. And that's Little's law in action in our system. Right, and this is usually the slide that gets people really angry with me. Because people tend to have strong feelings for or against story points. So let me just present my data, and then you'll decide if it makes sense for your team. When I joined the team about 1.5 years ago, we used to do planning poker and fingers in the air. So for a while, I kept track of the actual lead time and the correlation with story points. And what you can see here is that stories of 1 point were taking from 1 day to 10 days. Stories of 2 points were taking from 2 days to 20 days. and so on. So there is almost no correlation between the number of story points and the actual lead time. This might not be the case for you. This is what it looks like in our team. But I've seen other people present similar data. So I think the community is starting to realize that maybe story points are not working as well as we thought they would. And by the way, after seeing this, that's why we stopped estimating using story points, and we now just use our the lead time distribution that I showed earlier. Have you ever been to Disneyland or one of those theme parks? No one really? No, okay. So you know when you're in the queue to go and see Mickey Mouse, and you see those signs saying, from here you're going to wait for 1 hour, from here you will wait for 30 minutes. So a bit for fun, we created similar signs on top of each column on our board, and we say, from the development column, it's going to take usually from 5 to 9 days to get to done. And you're probably going to stay in this column for 1 to 3 days. So it's a kind of fun way to visualize your data on your board. This is something that has made us really predictable when a story is in progress. Before a story enters development, we have this policy that we have to identify a list of tasks on the story, and those are the tasks that we are going to implement as part of the story. It helps us to identify the scope of the story, but also to swarm effectively on the story, because different pairs can pick up different tasks on the same story. And we kept track of how long each task was taking. And we now know very reliably that 90% of the tasks take 5 days or less. So at stand-up, we usually look at how many tasks are left on a story to be implemented. And if there are still 8 tasks left, we know that's maybe 3-4 days left of work. So we probably want to put 2 pairs on it to try and speed it up. Or if there is only 1 task left, we might leave the guy on his own to finish the story. We don't have a big problem with quality. So we have quite basic metrics about our quality. We simply count the number of bugs and the number of stories, and we express it as a percentage. So we know that we have 13% of our stories are actually bugs, but we prefer to express it in this way. We have 1 bug every 6.2 stories. It's useful because if I'm planning, just a second, if I'm planning in the next 10 stories, I should probably allow for 1 or 2 cards to also jump in as bugs.
So when you say you get a bug, when do you actually find that defect? Is it on, for example, when you're branching out, when you do your integration testing back into develop, or is it when you're doing a progression? Or?
Mostly they're found in production, but they're not important things, so they end up just being kind of normal stories. And
is it an issue with a certain factor of third-party servers or something that causes HTTP? Do you ever find that this running value could vary while given certain phase of development versus certain?
no, not really, because we don't have bugs often, so really this simple count is enough for us. Like, we might go iterations without any bugs and then have an iteration with 1 or maybe 2, but it's not a big problem for us. So maybe you want to refine your metrics around bugs, but this was enough for us. And the only other thing that we do is we keep track of those tasks. We keep track about where they actually happened, just to demonstrate that even though we do so much release testing and all the type of manual testing for various political reasons, the only bugs that we find, the only interesting bugs, are found in production. So we try to do to raise the argument of why bother with this release testing. Let's just go to production and do monitoring rather than testing. It hasn't worked yet. But this is what our data is telling us.
The measurement there is the number of bugs you take into, you commit to completing, right? It's not the number of bugs that are raised.
Yes.
So that's the one that goes into your cycle.
But usually we look at all of them and decide this one is worth keeping and putting in a backlog, or this one is nothing and we just throw it away.
Okay. So would that figure not be affected by the prioritization of which you, what you take into that story? How do you just work on a queuing system? Or
we're only counting the appearance of bugs. It's a very rough indication of, but it's mostly for planning, to be fair, than to keep track of quality. Because if I know some bugs will appear, one every 6 stories, when I'm planning in stories, I should allow for some extra cards to also jump in. So if I'm planning for 10 stories, I'm actually planning for 11 or 12 stories. And the last few ones are about continuous improvement in general. And this one is my favorite. It's called flow efficiency. On our board, we have some columns that we defined in green, because those are columns that are adding value to the story. Someone is actively working on the story, adding some value to it, like development or testing. But then we have also all those columns that are simply queuing states or waiting states, like next, or the column in between development and testing. We have a waiting for testing. So we keep track of how long the story has spent in the value-adding states and in the queuing states, and we express it as a percentage, and that's our flow efficiency. And that's very interesting, because if you remember what Deming was saying, we can show you that it's not by asking people to change that we can improve a lot our performance, but by removing those queuing states, we could make our stories 50% faster. And my theory is that this is the effect of not having true cross-functional teams. Because in our industry, we label people with you're a BA, you're a developer, and you're a tester. You have the stories that have to wait for a developer to be available before the story can move from analysis to development. And then the story has to wait for a tester to be available. And all that time spent in hands-off is those queuing states. And that's because we still think that we optimize people by making someone just code and making someone just test. Hopefully one day we will get to one single job title, the team member, maybe. And the last one is very interesting if you've ever been in that situation when your project is late and your manager comes to you and says, I'm going to give you more developers. And most of us have been there. And this chart shows how long the story has spent in each state in different colors, both in absolute time and in percentage. And you can see that the development is the blue part. So adding developers, yes, would probably lower down the blue part, but actually it's the rest of the process that is making us so slow. So yes, we could improve the development time, because usually managers like to point their fingers at developers, but we won't improve much if we don't change the process, all the rest of the process. Oh, yeah, we also look at some stats for each individual state, but that's mostly to decide what state we should focus on next. And quick retrospective to wrap up. We like our metrics because they drive the changes to our process. They have enabled forecasting for us. We use metrics to decide what we should work on today. and the amount of learning that you can get from your data is almost infinite. You can keep changing it and reorganizing it, and you will keep learning things. Be careful about automation, especially at the beginning when you're learning about these things. I would suggest you do it manually for a while, and then you decide what to automate. We don't stress over precision, never. So even if you get one date wrong of one day, who cares? Your estimates used to be a lot worse. So we're looking at trends rather than actual numbers, so precision is not too important. Only keep the last n months, where n is something that makes sense for you. And remember that people still know it better. So you can have all the data you want and all the charts you want, but if your people are telling you something different, they might be right. Maybe you're collecting something in a wrong way. Maybe you're misinterpreting something. So still remember to trust the people that are doing the actual job. It's really hard to get the teams on board. So I had to do this manually on my own for a while until I had enough data to stop estimating, basically. So I had to do it by myself until I was able to say, hey guys, don't waste time estimating. I'll tell you how long it's going to take. And they were like, oh, okay, this is so cool. Yeah, we like the metrics now. Try and keep them simple if you can, otherwise people will have an information overload when they open your spreadsheet or whatever. Keep a diary of important events, so when you see a change in trends, you know what happened that made that change happen. And yeah, again, sometimes we forgot that we can't convince people just with numbers. You need to translate those numbers into feeling. You need to make them feel the problem and then show the demonstration with data. A bunch of books and links that you can follow. And okay, thank you very much. I'll be around.